Okay, I'm here to do an example problem on channel capacity, and what I'm going to do is first write down the equations that apply to channel capacity. The first one is the Nyquist equation, which says that the maximum bit rate is twice the bandwidth times log base 2 of the number of signal levels. And the second one is the Shannon equation, which says that the maximum bit rate, RB, is the bandwidth times the log base 2 of 1 plus the SNR, where the SNR is given as a ratio. And, okay, so those are the equations for channel capacity. And this problem starts out by saying we have an SNR of 20 dB and a bandwidth of 20 megahertz. So I'm going to go ahead and write SNR is equal to 20 dB, and the bandwidth is equal to 20 megahertz, or 20 times 10 to the 6th hertz. Okay, and part A asks for SNR ratio. Just a second, this is the SNR, right? Signal to noise ratio. But it's asking for as a ratio because the ratio is the value we have to plug into the Shannon equation. So this is a noisy channel, and therefore we're going to use the Shannon equation, which has the signal to noise ratio in it. And so, okay, so SNR, the equation for decibels, SNR in decibels is 10 log base 10 of the SNR as a ratio. And if we solve for the SNR as a ratio, this is one of our standard equations, we end up with 10 raised to the SNR in decibels over 10. And this is then 10 raised to the 20 over 10, 10 squared, or a signal to noise ratio of 100 as a ratio. So the signal is 100 times more powerful than the noise. Okay. Now it asks us for the theoretical maximum data rate for this channel, and I'm going to plug into the Shannon equation now. RB is the bandwidth times log base 2 of 1 plus the SNR. And this is then 20 e to the 6th. The bandwidth was 20 e to the 6th times the log base 2 of 1 plus 100. And you got to watch out calculating log base 2 on your calculator. Most calculators don't have a button for log base 2, and you'll have to use the fact that the log base 2 of x is the log of x over the log of 2. And you can use this equation. You just calculate the log of 101 and divide it by the log of 2. And you should practice this to make sure you can get it right. So I'm going to go ahead and do that. I'm going to take log of 101 and say that equals what? And that was 2. And then I'm going to divide by the log of 2. And this gives me a 6.65. So this is 20 e to the 6th times 6.658. I think, yeah, 6.658. And if I multiply this value by 20, I get 133.2. And I took the 6.65 and I multiplied it by 20. I didn't multiply by 20 e to the 6th, so I still have my e to the 6th here. And this is a bit rate, and so this is going to be a megabit per second. So this is 133 megabits per second. Okay? So this is how you solve this equation, and I hope this helps. Thanks for listening.